So in this problem, we've got to prove that all integers that are greater than or equal to 1, so n's greater than or equal to 1, and you've got to prove that that statement there can be divisible by 3 for any positive whole number. So we'll start with normal, start with the idea that n can equal 1, so 5 to the power of 1 times 2 to the power of 11, 2 times 11 to the power of 1 equals 27. So 27 is divisible by 3, so it's true for the first step. Now we're going to assume it's true for any value of n being equal to k, so we substitute k in there. And like we said before, if it's going to be divisible by 3, we could take our whole statement, divide it by 3, and it's going to equal some number m, where m is an integer. So again, rearrange it, suit your own needs. So 5 to the power of k plus 2 times 11 to the power of k is equal to 3m, or 5 to the power of k is equal to 3m minus 2 times 11 to the power of k. Now I've rearranged it that way. You could rearrange it with 11 to the power of k equals. I think it's probably easier this way. So what we want to do is prove it's true for n is equal to k plus 1. So if that's the case, we've got 5 to the power of k plus 1 plus 2 lots of 11 to the power of k plus 1. And remember when we play around with that, 11 to the power of k plus 1 is 11 times 11k, which gives us 22 times 11 to the power of k. And we're going to have 5 times 5 to the power of k. Now again, we want to get a substitution in there, and because we don't know whether this is divisible by 3 yet. We definitely can't tell at this stage. So let's make our substitution. 5k is equal to 3m plus 2 lots of 11 to the power of k. We're still at the plus 22 lots of 11k as well. So expand it out. 15m minus 10 plus 22 lots of 11 to the power of k, which gives us 12 lots of 11 to the power of k, which means we can factorise a 3 out of this part. Gives us 3 times 5m. 12 has a 3 factorised out to give us 11. Now we've got it divisible by 3 because 5m's an integer, and 11 to the power of a whole number is definitely an integer times 4. So that's going to give us a whole number, means it's divisible by 3, so thus it is true. Looking at the last example here, again, n's going to be greater than or equal to 1, so any positive whole number. 5 to the power of 2m plus 5 to the power of n plus 2 is it divisible by 4. So again, we show it's true for equals n is equal to 1. Throw 1 in there, gives us 25 plus 5 plus 2, gives us 32. That's divisible by 4, so we can see that. Again, assume it's true for n is equal to k. So we get our statement divided by 4 equals to m, where m's an integer, and then we can take our statement there, make sure it's equal to 4m because we multiply by 4, and then rearrange it. I'm going to rearrange it to 5 to the power of 2k is equal to 4 to the power of m minus 5 to the power of k minus 2 there. So manipulating again, we're going to prove it's true for n is equal to k plus 1. So we start off with 5 to the power of 2 lots of k plus 1, 5 to the power of k plus 1 plus 2. So that's 2k plus 2, which we could write as 25 times 5 to the power of 2k. Now you can see that that's how 5 to the power of 2k plus 2 is 25 times 2 to the power of 5 to the power of 2k when we rearrange and manipulate and decompose it. We've got 5 lots of 5 to the power of k, just clean that up, and plus 2. So notice we want to try and get everything back in the terms of 5 to the power of k. So we know that 5 to the power of 2k is equal to 4m minus 5 to the power of k minus 2 from step 2. 25's out the front, expand it out. So we get 100m minus 25 lots of 5 to the power of k. We're going to add 5 to the power of k there, and we're going to have 25 times minus 2 is minus 50, and we're going to have a plus 2 there. So now we're going to add our like terms, so 25 minus 25 plus 5 is minus 20, minus 50 plus 2 is minus 48, which we look at our terms and we can factorise a 4 out because it gives us 25m, that's an integer. 5 times 5k, that would be an integer, minus 12, which is definitely an integer, which means it's divisible by 4, so thus it must be true. So there's our way we work these ones out. We have to end up with getting a factorisation of whatever we need it to be divisible by out the front with our making sure we get an integer inside the brackets there.